The real numbers m and c are such that the equation x squared plus mx plus c squared equals 1 has a repeated root x, and also the equation x minus 3 squared plus mx plus c minus 1 squared is equal to 1 has a repeated root x, which is not necessarily the same value of x as the root of the first equation. Okay. How many possibilities are there for the line y equals mx plus c? Okay. So I think the most straightforward way to do this initially is to just treat these both as quadratic expressions for x and write down the condition. If you treat them as quadratic expressions for x and write the determinant, they'll both have a determinant that we can write in terms of m and c, and then just write down some equations for what m and c have to satisfy. Maybe we'll be able to figure out how many solutions there are to this. But I'm wondering if maybe there is a less tedious and more straightforward way of doing it by thinking of these as equations of lines. It's a little bit strange though, because you have an equation, you have a relation which gives you a line, or you have an expression which looks like a line, namely mx plus c. And then you square it. So the way that that looks is quite different depending on hold on, what if instead, because what if I have x squared plus mx plus c squared is equal to 1. What does it mean for this to have a repeated root? If I put everything on one hand side, expand everything, I get a parabola. Repeated root means that the parabola just grazes the axis. It becomes tangent to the axis somewhere. So, for example, if I look at this, if I think of that x squared minus 1, now, you know what, let me go with my first idea of just expanding things and writing determinants. I think it's going to get ugly though. So if this has a repeated root, this is always positive, so I don't need to worry about this thing actually reducing to a straight line rather than a parabola. But the determinant is 4m squared c squared minus 4m squared plus 1 c squared minus 1. I need that to be equal to 0. We can expand this. and I get m squared minus c squared plus 1 is equal to 0. Okay, so I need that to be satisfied. Now let's look at the other equation. X minus 3 squared plus mx plus c minus 1 squared is equal to 1. I don't really want to expand this, but if this is the approach I'm taking, this is pretty messy. I'm starting to think a more geometrical way of doing this would have been smarter. Okay, coefficients of x, I have 2m c minus 1 minus 6. Okay, and the determinant of this is that squared minus 4 m squared plus 1 c minus 1 squared plus 8. Oh my goodness, what a disaster this looks like. Yeah, this was not, this doesn't look like it was the right way to go about this. Okay, I'm going to take a different approach and try and wrap my head around what things are supposed to look like here. Just call that 0. So if I have a straight line, mx plus c, and if I square it, that becomes essentially, so I want to think of mx plus c, I want to think of it in terms of the x-intercept. When I square that, it looks like that. And then what does it mean for, but then when you add x squared, it completely shifts the, like where the vertex is. So one thing I think I'm going to do is I'm going to modify the second equation so that it becomes equivalent. So x minus 3 squared plus mx plus c minus 1 squared is equal to 1. Now, if I think of this as a straight line, shifted to the right by 3, that's the same as a straight line shifted down by 3. So what I'm going to do is I'm going to write this as x squared plus, I've shifted this line, I've taken this and I've moved it up by 3. I should just be able to take this. Do I have to also move it up by 3 to retain repeated roots? I have to change the right-hand side as well then. Let's think of it this way. I've just shifted both expressions up. Oh, wait. But the square is something that can mix this up. Well, shifting left and right should be fine. Now what happens if I expand that? And again, write out the determinant. Wait, that was right. This is disgusting. I guess I know that m squared plus c squared plus 1 equals 0, or maybe it was minus c squared. M squared minus c squared plus 1. So m squared c squared minus 1. Maybe I have some things now that cancel. Let's write this as c squared. I'm going to call that whole thing k. K squared minus k squared minus c squared k squared plus c squared is equal to 0. So I have c squared is equal to k squared. Okay, so choose k as anything. That gives you c is equal to k, or c equals negative k. Once you choose c is equal to k or c equals negative k, that forces m. So m so if I write 3m plus c minus 1 is equal to k. So if c is equal to k, I have 3m plus k minus 1 equals k. So m is equal to 1 over 3. Or I have 3m minus k minus 1 is equal to k. So 3m minus 1 is 2k. So m is 2k plus 1 over 3. So I get that there are two possible ways. You choose any constant and then choose c and m in this way according to k. So I get that the answer is 2, which is option C. There's got to be a more straightforward or intuitive way of doing this. A lot of the algebra here ended up being very messy. The first one through was kind of fine. Finding this first condition on m and c wasn't too bad. But then when you try and do the same thing here, I guess maybe that m squared plus 1 immediately becomes c squared. Maybe I just could have left everything the way it was. And I also hope that I did this sort of shifting substitution thing correctly. I just shifted everything horizontally by 3. That shouldn't change repeated roots and so on. So just let z equal x minus 3. So that's z squared. X becomes z plus 3. Expand in z. There should be a repeated root in z, which means the discriminant for that polynomial is 0. But yeah, I'm not going to try and go through and find if I had a mistake or anything like that, but I will check the answer and let you know if there's an error. But yeah, someone else can let me know in a comment if they came up with a more straightforward way of doing this one. Thanks for watching.